141, which the directions said to solve each formula for the specified variable. So that's f equals f sub 1, f sub 2 over f sub 1 plus f sub 2. This is always a tough problem for you guys. F sub 1, the reason it's tough to solve for is because it's in two different places. So people typically always start by cross multiplying. F times f sub 1 plus f sub 2 equals f sub 1, f sub 2. And kids want to just divide both sides by f sub 2 and call it a day. You can't solve for f sub 1 though and say, oh, f sub 1 equals an expression that also contains f sub 1. That's like using a definition of a word in its definition. So what we have to do is we have to get all of our f sub 1's together. So that means we should distribute on the left side so that we can subtract this one over. So f sub 2 equals f sub 1, f sub 2 minus, and I'm subtracting f sub 1 over. And now, in order to get there to be only one f sub 1 in the problem, I factor it out in front rather than distributing it through. I factored it out, and now I can divide this over. That cancels. F sub 1 is by itself, and it is defined without also using f sub 1. 111 was my next one, which is 1 over x plus 1 over x plus 2 equals 1 over 3. So getting a common denominator all the way across. This needs not a plus 2. You can't just ever add plus 2. It needs the entire factor x plus 2. This one, oh, it also needs a 3. This one needs a 3x, that x and that 3. And this one needs an x and an x plus 2. An x and an x plus 2. Then now double check. 3x, x plus 2. 3x, x plus 2. 3x, x plus 2. So all the denominators are the same and cancel, and so here's what we have. 3 times x plus 2 times 1, which is just 3x plus 6, plus 1 times 3x, which is just 3x, equals 1x times x plus 2, which I'll distribute, x squared, plus 2x. And it's become a quadratic. So I get it equal to 0. I'm going to subtract this 3x over, subtract this 3x over. That's a total of 6x. Subtract the 6 over. Aiden, was that a question? Okay. And then factor from here. Does it factor? Oh, I think it fell. 1 and 6, 2 and 3. So you need a quadratic formula, which is annoying, but is what it is. Opposite of b plus or minus the square root of b squared is 16 minus 4ac all over 2a. And then you would just go from there. And none of those are going to be restricted values. The only restricted values were 0 and negative 2, and that's not going to be one of the nice numbers that you get, so you don't have to worry about that. Are you sure, Aiden? Okay. 121 x minus root 2x plus 5 equals 5. Isolate the radical, so I'm going to subtract my x over. Now, having the negative on the radical, I'm just going to divide both sides by negative 1 to get rid of that. That's going to change it, really just flip the order of this. Really negative 5 plus x, but same thing. And now square both sides. The faster you can square over here, the better off you are. Subtract your 2x. Subtract your 5. X squared minus 12x plus 20. Is it factorable? 1 and 20, 2 and 10. X minus 10, x minus 2, x equals 10, or x equals 2. You need to check those. This is where extraneous can come up. So if I plug in a 10, I get 10 minus the square root of 25 equals 5. Is that true? Yes. So that works. 2 minus the square root of 9 equals 5. No. 2 minus 3 would be negative 1. So that one gets rejected. Always check for extraneous on those. 131. Oh, man. All right, I'll finish this. This will be cut up into 2 videos.